we see the 16 at the right. 16 can be 1 times 16, 2 times 8, or 4 times 4, as we saw up in problem number 1. It's 4 times 4, which make this 8. And so we know it's going to be an n. It's going to end up being plus 4 and n plus 4. Now when we see the same parentheses showing up twice, we prefer to have it written as n plus 4 quantity squared. That's just the general rule on how we write these. Problem number 6. We've got a 12 again. Nope, not again. We haven't seen 12 yet. 1 times 12, 2 times 6, or 3 times 4 are the choices. We need these to add up to a negative 7 in the middle, and 3 and 4 are going to be the numbers that do that for us. So each parenthesis will begin with a W. We're going to have a 3 and a 4 in our two parentheses, and they're both going to end up being negative, so the negative 3W and the negative 4W we get from the inner and the outer parts of FOIL will add up to that negative 7, and the negative times negative will make that positive 12. And so there is our factored answer. Number 7. Is there a GCF that goes into all three terms? Well, they're all even. I happen to see that 12 can go into each term. Dividing 12 out leaves p squared minus 8p plus 7. And then we can factor this into two parentheses of p times p. Again, 7's a prime number, so it's got to be 1 times 7. They both have to have the same sign to make that positive 7, and in order to add up to negative 8, they both need to be minuses. There's only one winning combination for each of these problems, and we've found it. Okay, problem number 8. Looks like we got a lot of y's there, so I can factor a y cubed out of each of the three terms. It also looks like we can factor out an x. So x, y to the third will divide out, leaving us x squared minus 19x plus 6d, and that's it. Now 6d is a bigger number, but I'm going to use the same process. 1 times 60, 2 times 30, 3 times 20, 4 times 15, 5 times 12, 6 times 10. And I've already passed the one that we were looking for, the 4 times 15. We leave the xy to the third out front. We get two parentheses, each beginning with x. And we know it's got to be a 4 and a 15 making the 60. We got the F and the L locked in. Both signs need to be the same to make that positive 60, and they both need to be negative to make that minus 19. There we go. Number 9. A negative leading coefficient means we can factor a negative out. It turns we can factor the 2 out also, leaving us m squared minus, watch your signs, minus 11m plus 10. Leave the negative 2 out front. Split it into two parentheses, each beginning with an m. That 10 is just kind of staring at me, 1 times 10, making the 11 also if they're both negative. If you want to check your work, you'd have to do all the multiplication and verify you get back up to that top line. Number 10. We see 5's everywhere. I'm going to divide a 5 out as a greatest common factor, leaving w squared minus 8w minus 9. And then, again, here we go. W times w will make the w squared. 9 can either be 1 times 9 or 3 times 3, but 1 and 9 do the trick. I'm going to be careful with my signs here. I'm going to have a 1w on the inner and a 9w on the outer. I need to make it minus 8, so a positive 1 and a negative 9 will add up to that negative 8 in the middle. So 5 times w plus 1 times w minus 9 will be the numbers that do the trick for us.